just a few different product rule, quotient rule type problems. So let's take a look at this one. Y equals x minus 1 times x squared plus x plus 1 over x cubed. Now use some options in terms of how you proceed here. They're asking you to find y prime. One thing you could do is you could distribute out the x on top and then go and distribute out the negative 1 on top and get rid of the product rule that's in the numerator. So you have that option. I'm not going to do it that way. I'm just going to go straight to the derivative. So here we go. The derivative would be bottom function times the derivative of the top. So it would be x cubed times, and here's where you have to be really careful. When you go to do the derivative of the top, so this is a product rule within a quotient rule. So here we are. Now we look at the numerator here, and that's going to be the first function, and that's going to be the second function. So here we go. First, the second, plus the second function, the first, which is just 1. Okay? So that finishes off first low d high, or bottom times derivative of top, minus the top function. I'm out of room already here. X minus 1 times x squared plus x plus 1 times the derivative of the bottom, which would just be 3x squared. And then it's over the bottom squared, so that's x cubed squared, which if you want, you could write as x to the 6th. Now, you could try and reduce this and combine like terms. It would eventually simplify to something. I'm not going to bother now, but that would be an exercise for you to try. All right. Be careful of a problem like this. Y equals 1 minus x times 1 plus x squared to the negative 1. Okay? Sometimes they decide to write things in a strange way, but if you remember what negative 1 means as an exponent, that just means put that thing in the denominator. So it's y equals, bear with me for a second here, 1 minus x over 1 plus x squared. Okay? So there you can clearly see that you could use the quotient rule. Okay, so let's do that, and then we'll mention one thing before we leave this. So it's usually bottom function times the derivative of the top is negative 1 minus the top function times the derivative of the bottom over the bottom squared. This one that wouldn't take too long to simplify if you wanted to. You could distribute that negative 1. You could distribute the 2x. And then don't forget to distribute the negative onto both of those and combine like terms, and you get something maybe a little simpler. Okay? Let me make one comment here. Some people might look at this and think, hey, wait a minute. Can't I do a product rule? Right? It looks like a function times a function. The answer is yes, but there's something you haven't learned yet. When you do first, d second, the derivative of this thing is a little bit tricky. And the reason it's a little bit tricky is because you have a function 1 plus x squared inside of another function, something to the negative 1 power. And when you ever have a function within a function, to do that derivative, you'd need something called the chain rule. So if you know about the chain rule, then it would be possible to do this thing with a product rule. So let's take a look at another problem. So suppose they tell us the following, that u and v are differentiable functions. All right, so you're going to see that you're going to hear that fancy word differentiable. I'm abbreviating it DIFF, but differentiable just means that this thing has a derivative. Okay? And then they might say something like this. What's d dx of u times v? So it might seem a little obscure at first, a little abstract, but I think you wouldn't have had a problem if you were given this problem. So for example, suppose they said find d dx of x squared times the sine of x. I think most people look at that and go, oh, okay, I know how to do the derivative of those things. That's a product rule, because I have x squared, I have this function times another. So the answer would just be first d second plus second d first. And you'd write down the answer and you'd be fine. Well, my claim is that the problem you were given is even easier. This is the first function. That's the second. They're telling me they're functions. I don't know what they are. But if I was going to do the derivative, I would just do this. U, which is the first function, v prime, which is the derivative of the second, plus the second function, v, times the derivative of the first, u prime. Now, it's also possible that maybe you'd be given some information about u and v. So the problem that I'm getting this from says the following. It says that u is equal to 5, and u prime is equal to -3, and v is equal to -1, and v prime is equal to 2. These were all evaluated at x equals 0, by the way. So I could have written u of 0 equals 5 and so forth. But all you got to do now is, if you were given these facts, is plug them in. So we'll take these pieces of information and just plug them into the correct location. That's what you would do. So you would end up with 5 times v prime here, which is 2, plus v, which is -1, times u prime, which is -3. And if you multiply all that together, you would get 13. Okay? All right. So we're going to keep these facts here. All right? We're going to keep those. We'll copy them. We'll go to a new page, and we'll answer a different question now. So let's pretend they'd said, find d dx of v over u. Okay? So now what they're really saying is find the derivative of this quotient of two functions. And you know, to do the derivative of a quotient, you use quotient rule, which says bottom function, or low, d high, derivative of the top function, minus the high function, times the derivative of the bottom, or d low. I always say low d high minus high d low over the bottom function squared, or low squared. Okay? There it is. That's all you have to do, and you plug in all the facts. Take the time to do that. U is 5. V prime is 2. Minus v, which is -1. U prime is -3 over u squared, over 5 squared. Let's see what we end up with here. We end up with 10 on top minus 3 over 25, which would be 7/25. Okay? Let's do one more problem utilizing this idea. Get those facts up here again. So let's pretend they said find d dx of 7u minus 2v. So sometimes people get confused when they see 7 times u and they're not quite sure how to do the derivative of that. I'll say it a couple ways. I'll show you a couple ways to do it. One thing you could do is think of this as like a product rule temporarily, as like 7 times u. Now, I would not recommend this, but if you did it, it will work. Watch what happens. First d second plus second derivative of first, which is 0. So the whole thing just turns out to equal 7 times u prime. Right? So if you look carefully at it, what you notice is, to take the derivative of 7u, the answer is just 7u prime. So you just take the derivative of u and you multiply it by 7. So that's the fast way to do it. I wouldn't use product rule. Using the same reasoning, this should be 2v prime. So your answer is 7u prime minus 2v prime, and you just plug in the two values. So what do we have here? We have 7 times -3 minus 2 times 2, which is going to be -21 minus 4, or -25. Okay? So that's how that works. The other way to reason this is to think about what you already know. So suppose, for example, I gave you y equals 7x squared, and I asked you to find the derivative. Okay? Here's what you might do. Most of us would say y prime equals, you bring the 2 down in front, you do 7 times 2, you get 14, and then it would be x to the first power. Right? That's what would happen. But here's just, I'm just going to write it slightly differently. I'm going to think of this as y prime being 7 times the derivative of x squared, which is 2x to the first. So you'll notice I'm just sort of saying I'm going to think of the 7 as being the coefficient. Here it is. Here's the 7 here. Here's the 7 here. And if I take the derivative of this x squared, that thing by itself becomes 2x to the first. And then I can multiply them afterwards. And you'll notice I'll get 14x to the first, which is the same thing I know from my normal power rule. So this just sort of shows me that if I want to take if like y equals some function u, or say, let's say 5 times u, then y prime is just 5 times u prime. The coefficient just carries down and gets multiplied by the derivative.